Dear students, I welcome you to this lecture on game theory, strategic decision making. At the end of this video, you will be able to understand the fundamental concept of game theory, able to solve game theory problems related to pure strategy, mixed strategy and dominance property. And you will be able to develop problem solving skills with clear reasoning and simple logics. Introduction. Every day we take decisions. Based on the decision we take, we reach to the destination. So it is very important to take the decision in right manner. So in company, every day they used to take a decision to get more profit or to minimize the maximum losses. So here this game theory will help to take the right decision to get maximum profit or minimum losses. So this type of situation will be arises in business field, industry, economics and social and military training. So this game theory will be helpful to take a decision in these fields. There are three types of games we used in operations research. The first one is pure strategy. So that means he may have 4-5 options. Out of 4-5 options, he will be the selecting only one option. That means only one strategy irrespective of the opponent strategy. So this type of strategy is called as a pure strategy. Next one is a mixed strategy. So player select the randomly, he will select the different strategies based on the probability of getting the profit or the getting the minimum losses. So that type of strategy is called as a mixed strategy. So the third one is dominance property. Dominance property is a strategy. So when they will be comparing the two the strategies, which one is more dominating, so based on that the player will take the decision. So that type of strategy is called as a dominance property. So here two people are playing game. In that I am actually tossing the coin and other person, opponent person, is guessing the coin. So here if he properly guess the coin, the toss, he will be getting 1 rupee. If he is unable to guess the toss, he will be losing 1 rupee. So that is the game they are playing. So here he properly guessed the toss, so he is getting the money, and other time he is failing to guess the toss, so he is losing the money. So that is the simple game. So let us see how to solve this problem in the next slide. So based on the video we see, we will try to understand some terminology. So here the player A and player B, two people are playing in the video. So the first strategy is head, the second strategy is tail. So these are the strategies. He can select either head or either tail. So that is called as the strategy. So then there is a rule saying that if the opponent, the player A, guess the head properly, then he will get 1 rupee. So that means +1. And that means when there is a head and head matches, that means the player B will lose 1 coin and 1 rupee, and that will be given to player A. And if suppose if there is a head, but he is unable to guess properly and he said only tail, that means in that case the player A will give will give 1 rupee to player B, so that is lost to him. So in this that becomes it becomes -1. So this table is called as payoff matrix. So here if you observe, so this table is called as a payoff matrix. So based on this table only, whether player A or player B will receive the money, so that will be understood. So these are the basic terminology you need to use in game theory. So first one is the strategy. So head or tail are the strategy which the player A and player B both will have the option to select, and this matrix is called as a payoff matrix. Based on this, either player A or player B who is getting the money, so that this payoff matrix will be showing. So let us see one problem based on this. So this problem we will solve in another time, but let us see some problems based on the three different problems we have seen in the previous slide. So that is the pure strategy, mixed strategy, and then the dominance property. So one by one we will see the problems. The first one is the pure strategy problem. So the problem is given like this: a payoff matrix for player A and player B is given below. Determine best strategy for each player and value of the game. So as I told you here, there are two players, player A and player B. The player A having three options, 1, 2 and 3. So player B also having the same the strategies 1, 2 and 3, and this table is the payoff matrix. So it says, if suppose if they select the first strategy, both of them, so the player B need to give 2 rupees to player 1. So here all the values are in positive. That means the entire matrix shows the relation between player A and player B. So all things are positive. So player B will be giving money to player A. So that means which one is the prominent to select for player A and player B, such that it will become optimum. So that is what we are going to see. So first in pure strategy, because the player A and player B, they will be selecting only one strategy which will be giving more profit to them. So let us first see, we are always the understanding these problems as we are as a player A and a player B as the opponent. So that is why this payoff matrix is in the positive matrix. So that means all the values are in positive. So now let us try to solve this pure strategy problem. So in this pure strategy problem, first player A, he need to get maximum profit. That means he need to maximize the minimum losses. So that is what the player A, he need to get it. So that is why we will apply a max mini principle and mini max principle in order to solve this problem and find the value of the game. So if you see the max mini and mini max principle, so from this payoff matrix, so first there is three rows and three columns. In the first row, we will be first seeing out of these three the payoff elements. So we will be first selecting what is the minimum value. So here the for player A first strategy sorry if you observe this payoff matrix, the player A first strategy is having 2, 4 and 5. So out of these three elements, the 2 is the minimum value. So we will write minimum value 2 here. In the second row, the minimum value is out of 10, 7, 6. The 6 is the minimum value. So I will write 6 here. And in the similar manner, third row, the 3 is the minimum value. So out of this 3, the which one is the maximum value? So that becomes max mini in this row. So max mini will represent, we are going to maximize the minimum losses. So maximize the minimum losses. So here the 6 is the max mini value. The similar manner, if you take for row, so mini max value, So minimax value represents minimizes the maximum losses. So minimizes the maximum losses. So it will that also will see in a row wise. In the first row, the maximum value is out of first column. Sorry, in the first column, the maximum value is 10. Out of 2, 10 and 4, 10 is the maximum value. In the similar manner for the second column, so 4, 7 and 8. Out of these 3, the maximum value is 8. And third column, the maximum value is 6. So out of these 3 values, we need to see what is the minimum value out of 3. So that becomes a mini max value. So that mini max value will become a 6. So here the max mini value in the player A is 6 and mini max value for the player B is a 6. So these two are becoming equal. So that is called as saddle point. So this 6 is called as saddle point. Whenever the minimax value is equal to the max mini value, then that value that is called as a saddle point. Whenever saddle point arises, that is called as the pure strategy. So the pure strategy, the value of the game is the saddle point. So here in this problem, the saddle point is the 6. So the value of the game is 6. So what is the optimal strategy of player A? Because the saddle point exists in the second strategy for player A, so second strategy is the optimal strategy for player A. In the similar manner, the first strategy, the third strategy is the optimal strategy for player B because saddle points exist in the third strategy. So that is how we are going to see what is the optimal strategy for player A and player B, and the value of game is 6. So what it actually this result says? So this result says if the player A select a pure strategy, that means a second strategy, and player B select a pure strategy, that is third strategy, the value of game is 6. That means the player A will get 6 points from player B if they select this optimal strategy of the game. So out of this the strategy, if they select any other strategy, that will be losses for the respective company. So for example, if player A select the second strategy, and player B unknowingly if he select first strategy, then he will be losing 10 points. That means it is gain for A, but it will be loss for B. It is not the optimal one. And if suppose player A by mistake, if he select a first strategy and the player B select a second strategy, so then the player A will get 4 points. Still it is loss, because if he select second strategy, he will be supposed to get 6 points. So that is loss to A. So that is how we need to understand this the problems, game theory problems. So let us see one more problem, the industrial problem, so that we will be able to understand this selecting the strategies in more clearly. So you try to read this problem. There are two companies. These are the two computer hardware manufacturing companies. So company A and company B are competing for supplying computers to government department. Each company has listed its strategies for selling computers. So if they give more offers, so people will be attracted, and their computers will be sold very easily. So that is why they have taken these three strategies on each company. So the strategy of computer A, they have taken a three strategies. The first strategy is giving special price. So on MRP they are giving us some special price. So that is the first strategy. That how much special price they are giving, that is not actually mentioned here, but a strategy is giving a special price. And the second strategy is giving 20% worth of additional hardwares. So apart from the MRP rate, they are giving 20% worth of additional hardwares. So that is the second strategy. Third strategy is supplying computer furnace free of cost. So that is the third strategy. So only supplying computer furnaces, whatever is required for that computer. So that is the third strategy. These are the three strategies company A is showing, so that the people will be attracted by seeing these the strategies. They will be offers, by seeing these offers they will be attracted. And then because company B, if they don't give any offers, nobody will purchase from company B, then they will not have any sales, then they will be in loss. So that is why the company B also started giving some the keeping some strategies for the selling the product, the computers. Those strategies are the strategies of company B, giving a special price. So that is not given how much special price, but giving a 30% worth of additional hardware. So 30%, they given 20% worth, and these people are saying 30% worth of additional hardware. And the third strategy is giving free training to the users for organizing which is the buying, the determine the optimal strategy. So the third strategy is giving pre-training to the users of organization, so who are buying the product. So that is the third strategy. So after they give these strategies, they analyzed how much each strategy will take money from a company. So that means they are giving offer, so how much they will be getting loss. So company A and company B, based on the strategies they are following, how much they are going to lose. So they have done an analysis, so that analysis is given below. So that is nothing but the payoff matrix. So they are saying that the payoff matrix values are given in lakhs. So here the company A and company B, there are two companies. If they select first strategy, second strategy and third strategy, so correspondingly how much the company A will be gaining and how much company B will be the losing, so that the statistics are given here. So here, so that is the values are given in a payoff matrix. Based on these values, so company A and company B, they need to select any one strategies for selling their component. So based on that, they can able to take the decision. So now let us solve this strategy. Let us solve this game theory by using the pure strategy. So first, what we will apply? We will apply max mini principle. So we will be taking the payoff matrix. So player A and player B are given here. First we will calculate the max mini, the value. So for the first row, the minimum value is 13. So the second row, out of these three elements, the minimum value is 35, and third the row, the minimum value is 18. So out, and again for a mini max value, so for first column the the maximum value, so mini max value we are going to take the maximum value, so 35, and in the second strategy is 45, and third strategy is the 40. So here we are going to see what is the max mini value. So these are the minimum values in the row. So out of these rows, what is the maximum value? So that is 35. And again in the the maximum values in the column, what is the, out of these three, what is the minimum value? So that is 35. So that means here mini max value is equal to max mini value. So when mini max value is becoming equal to max mini value, that means it is a pure strategy problem. So the value of the game is the saddle point. So here the saddle point is 35. So value of the game is 35. But now the player A and player B, which strategy they need to follow? So wherever the saddle point exists, that strategy they need to follow. That is only optimum strategy for them to get get maximum profit or minimum losses. So player A, now the saddle point is existing for the second strategy, and player B, the saddle point existing in the first strategy. What it means actually? Now you go to the strategies which we discussed in the problem. So that means the player A, he need to select so player A, he need to select second strategy. So and player B need to select a first strategy. So what is the second strategy for player A? The player A second strategy is giving 20% worth of additional hardware. So out of these three the strategies, if they follow a second strategy that is giving 20% worth of additional hardware, that will increase their sales, and that will increase their profit. That increasing of the profit is 35 lakhs per year. And if suppose the company B, if they give the first strategy, if they follow first strategy, that is giving special price, so that only a optimum strategy for company B, that shows they will be losing only 35 lakhs if they follow only this first strategy. Out of that, if they follow second or third strategy, the amount they are going to losses will be more compared with the first strategy. So for optimum strategy for company B will be only first strategy. So that is how we are going to solve the problems in a pure strategy. So next problem 3 on mixed strategy. So payoff matrix for player A and player B is given below. Determine best strategy for each player and value of the game. So here player A and player B are given, and the payoff matrix also given. So here this is also we can try to understand like head and tail strategy. So for example, if player A guess correctly, if it is a head, he will gain 2 rupees, and if he guess the tail also, but he will not gain anything, so that is a 0. And if he is unable to properly guess the tail or head, then he will be losing 1 rupee. So in this way this game will go. And how we need to solve this mixed strategy problem, we will see. So first of all, if you check the pure strategy for this problem, so there won't be a the saddle point. So we need to analyze another solution, another method to solve this mixed strategy problem. So let us see mathematical solution for this mixed strategy problem. Let us try to consider player A plays H with probability X, then T with probability 1 minus X. So that means if the probability X is the probability when player A plays with only head, and then the probability for playing with the tail will become 1 minus X, because the total probability should become the 1. So 1 minus X plus X, it becomes 1. So then if the player B plays H all the time, then A's expected gain will be. So for example, the player B plays only the first strategy, that is head, then how much player A will get? So that is 2 into the probability of X minus 1 into probability of tail, that is 1 minus X. So then it will become 3x minus 1. Let us say this is the equation 1. And if the B plays T all the time, tail only all the times, the A's expected gain will be, and the E of A T, the expected gain of A with the tail will be, and it will be minus X into minus 1 into X plus 0 into 1 minus X. So it will be minus X is the expected gain for player A, and that is, let us say, equation 2. So this can be mathematically derived as, mathematically player A choose X such that the expected gain of A when he played the tail will be equal to the head. So that becomes 3x minus 1 is equal to minus X. So X will become 1 by 4. The probability of player A plays strategy H, that is P1, is equal to 1 by 4, because this is X. And the probability of player A plays strategy T, it becomes P2, that will become 1 minus X, that value will become 3 by 4. And by substituting the X value in equation 1 or 2, we will get the value of the game, that is equal to 2x minus 1 into 1 minus X, that it becomes minus 1 by 4. So that is how we are going to solve mathematically. So this we write in terms of equations, so we can get the solution. So let us try to analyze A, B, C, D are the payoff matrix for player A and player B. The probability of selection of alternatives of player A, let us say P1 and P2, and the P1 will be the determinant of C minus D by determinant of A minus B plus the determinant of C minus D, and P2 will be the determinant of A minus B by determinant of A minus B plus determinant of C minus D. And similar manner, the probability of selection of alternatives of B, let us say Q1 and Q2, then the Q1 will become determinant of B minus D by the determinant of A minus C plus the determinant of B minus D, and Q2 will be equal to the determinant of A minus C by determinant of A minus C plus determinant of B minus D. So the value of the game, we can derive the equation, that is V is equal to B of determinant of C minus D plus D of determinant of A minus B divided by determinant of A minus B plus determinant of C minus D. And there are four equations. We can use any equation, we will get the same solution. So these are the formulas to get the probability of the P1, P2, Q1, Q2 and the value of the game. And we can use these equations and we can directly get the solution. Or else we can also use another alternative method, that is augment method. So according to this augment method, we are going to first find the augments. So for augment of this first strategy will be the difference between this C and D, and determinant of C minus D, it will become 1. So that we will be writing here, and that becomes the augment for first row, and augment for second row will be the determinant of first row. So that means the determinant of the 2 minus of minus 1, so that becomes a 3. And a similar manner we will be finding the augment for the row. So augment for the first row will be the difference between 1 minus 1 0, so it becomes the 1, and augment for the second column will be the difference between these two, 2 minus of minus 1, it becomes a 3. And now the probability of first strategy, when the player A plays, the probability will be the P1. The P1 will be equal to 1 divided by 1 plus 3. So that means this value divided by the sum of these two values. So that becomes 1 by 1 4. And the P2 will be this value divided by this two value. So 3 by 4. The same manner we can find Q1 and Q2, and Q1 will be this value divided by sum of these two values, that becomes a 4. Q2 will be this value divided by sum of these two values, so that becomes a 3 by 4. So now the value of the game will be, so these two values we need to multiply with this two values, then you will get the V value, so the game value. So that means 2 into 1 by 4 minus 1 into 3 by 4. So that value will become 1 by 4. So therefore we can say that the strategy of player A is in the probability of A of 1 by 4 comma 3 by 4, and strategy of player B is in the probability of B of 1 by 4 comma 3 by 4. The value of the game will be minus 1 by 4. In this way we are going to solve the problem. So let us try to solve another problem by using this mixed strategy. And the problem says the payoff matrix for player A and player B is given below. Determine best strategy for each player and the value of the game. And player A and player B payoff matrix is given, that is 6 9 8 4. So this can be solved by two methods. One is analytical method, or maybe augment method. So we will try to solve this by augment method. So here we will find the augments first. So here are the augments, and then the augments for first the row will be difference between these two, so that becomes a 4, and second the augment for the second will be the difference between these two, so it will become 6 minus 9, determinant of 6 minus 9, it will become the 3. And the same manner we will be finding the augment for the column. The column augments will be difference between these two, 9 minus 4, it will be 5, and the difference between these two will be 2, that will be in the second column. So now we can find out the P1, P2 and Q1, Q2. The P1 is equal to 4 by 4 plus 3, that is 7. P2 is equal to 3 by 4 plus 3, that is 7. And Q1 is equal to 5 by 5 plus 2, 7. And Q2 is equal to 2 by 2 plus 5, 7. So now the value of the game is equal to the 6 into 4 by 7 plus 8 into 3 by 7, that is equal to 48 by 7. And the 6 into 5 by 7 plus 9 into 2 by 7. So both are same. So whether you multiply this with these two values, or this multiply with these two values, or multiply these two values with these two values, so we will get the same V value. So finally we can say the strategy of player A is in the probability of A of 4 by 7 comma 3 by 7, and the probability of B is in the probability of the B of 5 by 7 comma 2 by 7, and the value of the game is 48 by 7. And next method is the problem 5 will be the dominance property, and here the problem will be given like this: payoff matrix for player A and B is given below, determine best strategy for each player and the value of game. And player A and player B, and there are three strategies, 1 2 3, and then this is the payoff matrix. Now this is a if you check, this is not a pure strategy, because if you find the minimax value here, and here the minimax value here is the 2 minus 1 2, and the max mini value will be 6 3 and 4. So the minimax value is not equal to max mini value, so we can't this is a mixed strategy problem. So but mixed strategy problem we can't solve if it is 3 by 3. So we need to eliminate some of the rows or the column by using a dominance property method. So here there will be some rules and regulations for deleting rows and column that we will see. In a dominance property, rules for row reduction, or the dominance principle for row reductions, are given below. So if all the entries in row are less than or equal to corresponding entries of another row y, in this situation row can be deleted from payoff matrix. And if another row z is less than or equal to x plus y, then row z can be deleted. So these are the two principles for row reduction. And let us see the dominance principle for column reduction. If all the entries in the column x are greater than or equal to corresponding entries of another column y, then in this situation column x can be deleted from the payoff matrix. If another column z is greater than or equal to x plus y, then column z can be deleted. So these are the principle for row reduction and column reduction. So here we need to remember one thing, that is whenever there is a less than or equal to value, so we need to delete that x from the payoff matrix in case of the row reduction. In case of column reduction, greater than or equal to value are there, the first thing x or z, whichever is there in the first, that can be deleted. So if you remember these two, the greater than or equal to for the row reduction, and less than or equal to for row reduction, and greater than or equal to for column reduction, so we can easily solve these problems. So let us solve this problem with the dominance property. So before we apply, we first see the minimax and max mini value. So here the minimax value is these are the minimum values. Out of this, the maximum value is 2. So and these are the maximum values in the column, and the minimum value out of this is 3. So the minimax value is not equal to max mini value. So this is not the pure strategy problem. So it is a mixed strategy problem. So if it is a mixed strategy problem, if it is a 2 by 2 row, 2 by 2 the payoff matrix, we can directly use analytical method or augment method. but because this is the 3 by 3 the payoff matrix, we need to reduce the columns and rows such that finally 2 by 2 matrix will be existing. Then we can apply augment method or maybe analytical method. So now let us apply the dominance property rule for row reduction and column reduction. So now first we will compare first strategy with the second strategy, and we will see whether any strategy is dominating other strategy. So what is the principle? So if all the entries of strategy 1 are less than or equal to the another strategy, then whichever is less, that can be deleted from the payoff matrix. Now let us compare these two. So now if you compare the strategy 1 with the strategy 2, so if you compare the strategy 1 with the strategy 2, so the strategy 1 is dominating, and again the strategy 1 in the second elements, so 2 is greater than minus 1 is less than or equal to 2, so that is again the strategy 1 is dominating. So when you compare these two, though, and again 4 is dominating 1, so that means if you compare the strategy 1 and strategy 2, the strategy 1 is dominating strategy 2 in all the entries. So we can able to delete the second strategy from the payoff matrix. So let us delete the second strategy. Now let us compare the strategy 1 with strategy 3, and here the 2 is less than 6. So the strategy 1 is dominating strategy 3, and here the 2 is less than 3, so the strategy 3 is dominating strategy 1. That means either strategy 1 is not dominating strategy 3, or strategy 3 also not dominating strategy 1. So either A1 is dominating 3, nor the 3 is dominating 1. So that means we can't delete any row further. So now let us write another payoff matrix with 2 rows. So if you write with the strategy 1 and strategy 3, so this will be a 2 by 3 matrix. Now we will come to apply the dominance property principle for row reduction. If you come to row reduction, so you compare strategy 1 with strategy 2. So the 6 is dominating 3, but 2 is not dominating 3. So that means either 1 nor 2 is dominating each other. Now let us compare 1 with 3. So here the 6 is dominating 4 and 2 is not dominating 3. So that means either 1 nor 3 are dominating each other. Now let us compare 2 with 3. So now here 4 is dominating 2. So 4 is dominating 2. So again 3 is dominating 3. So that means the 2 is less than or equal to 4, or otherwise 4 is greater than or equal to 2, and 3 is greater than or equal to 3. So that means these two are equal. So that means strategy 3 is dominating strategy 2. So here whenever something x is less than or equal to y, so x will be deleted in the column reduction. So here the 4 is greater than or equal to 2 and 3 is also greater than or equal to 2. So whichever is dominating, that will be deleted. So here strategy 3 will be deleted. So then the finally we are going to get a 2 by 2 matrix now. So once after you get a 2 by 2 matrix, we can easily apply augment method and we can solve it. Let us apply augment method for this. So if you apply augment method for player A and player B, so we will be finding the augment values. So here the augment value is difference between these two, 2 minus 3, that is equal to 1, and here the augment value 6 minus 2, the difference will be 4, and here the difference between augment value for column, the difference between these two values, so that becomes 1, and the difference between these two value, the value will become 6 minus 2, that is 4. So now you find out the P1. P1 is equal to 1 by 1 plus 4, so 1 by 5. P2 is equal to 4 by 1 plus 4, so that becomes 4 by 5. And a similar manner, the Q1 and Q2, Q1 is equal to 1 by 1 plus 4, that is 5, and Q2 is equal to 4 by 1 plus 5, so that becomes, and the value of game V is equal to 6 into 1 by 5 plus 2 into 1 by 5. So, sorry, 4 by 5. So the value of the game V will become 14 by 5. So finally we will say strategy of player A is in the probability of A of, now first strategy 1 by 5, and second strategy is not there here for a player the A. So that becomes a 0. Actually here it should be 0, and then third strategy will be 4 by 5. So here will be 4 by 5. And in the similar manner for the strategy of player B in the probability of 1 by 5 comma 4 by 5 and then 0. So here actually these probabilities are interchanged for player A and player B. So please note. And the value of the game V is equal to 14 by 5. So that is how we are going to apply the augment value once after we get the 2 by 2 matrix. Now let us see one problem related to graphical method. So consider the payoff matrix with respect to player A and player B and solve it optimally using graphical method. So here the 5 by 4 matrix is given. 5 by 4 matrix is given. So we need to solve this problem. So any problem they will be sometimes they will not be asking you to solve it by graphical method, but whenever they ask some problem, so we need to first apply the minimax value, and then we will go to the dominance property. Then we will try to reduce the columns. If it comes to 2 by 2 matrix, we can directly apply the augment value. If you don't get the 2 by 2 matrix, then we can apply a graphical method. So that is the advantage of graphical method. When we can't solve with the analytical method, dominant property, we can't get 2 by 2, then we will use the graphical method. So let us solve this problem, then we will understand this concept. So first we will apply max mini and mini max criteria. So for this problem, so if you find the max mini value, so what is the minimum value in this row for the row? So the minimum value will be -2, and the minimum value for second row will be -1, and the minimum value in the third row will be -2, and the minimum value in the fourth row will be -1. So out of these 4 minimum values, what is the maximum value? So that becomes a max mini value, that is -1. The similar manner for mini max value for column, so maximum value in the first column will be 3, the maximum value in the second column will be 5, maximum column in the third column will be 6, maximum column in the fourth will be 2, and maximum column will be in the fifth will be 7. So out of these 5 columns, the minimum value will be 2. So here the mini max value is not equal to max mini value, so it is a mixed strategy problem. So we need to go for the row reduction and column reduction by dominance property. So let us apply dominance property for this the payoff matrix. So this is the payoff matrix, and we will apply dominance property. So first we will compare strategy 1 with strategy 2. So here the strategy 2 is dominating strategy 1, and in the second column if you observe the entries, so the column first strategy is dominating second strategy. So that means either strategy 1 nor strategy 2 is dominating each other. And now let us compare strategy 1 with strategy 3. So here the strategy 1 minus 2, which is dominated by strategy 3 minus 1. So the minus 2 is less than or equal to minus 1. And again here the 3 is less than or equal to 5. So again strategy 3 is dominating strategy 1. And here again minus 2 is less than or equal to minus 2. So the strategy 3 is dominating strategy 1. And 1 is less than or equal to 2. So the strategy 3 is dominating strategy 1. And 0 is less than or equal to 1. So the strategy 3 is dominating strategy 1. So all the entries of strategy 3 are dominating strategy 1. That means strategy 1 can be deleted. So the strategy 1 can be deleted from the payoff matrix. So we will strike out the first strategy. And now let us compare the remaining. So let us compare third strategy and fourth strategy. So the fourth strategy is dominating third strategy, and but 0 is dominating the third strategy. So that means either third nor fourth are dominating each other. Now let us compare second strategy with fourth strategy. So when you compare second strategy with fourth strategy, so the second strategy is dominating fourth strategy because 2 is less than or equal to 3, 0 is less than or equal to 0, 5 is less than or equal to 6, minus 1 is equal to minus 1, 6 is less than or equal to 7. So the strategy 4 is dominated by strategy 2. So the minus 4, the fourth strategy is less than or equal to second strategy. So the fourth strategy can be eliminated from the payoff matrix. So now we got only 2 by 2 matrix, 2 by 5 matrix. So let us write the payoff matrix separately. Now if you write a payoff matrix for 2 by 5 matrix, so this is the payoff matrix. Now let us see again, let us go to the column reduction, because we already compared second strategy with the third strategy, which nothing is dominating, either 2 nor 3 are dominating each other. So we will be seeing the column reduction by dominance property. So now let us compare let us compare first strategy with 2. So here 3 is dominating the second strategy, and first strategy is not dominating second strategy when you compare this other entry. Now let us compare 1 with 3. So here the 6 is dominating 3, but minus 2 is not dominating minus 1. So again you compare 1 with the 4. So 3 is dominating minus 1, but minus 1 is dominating 2. So 3 is dominated by 7, but minus 1 also dominated by 1. So here with this, the strategy 5 is dominating strategy 1. So in this case, so the fourth strategy is greater than or equal to first strategy. So the fifth strategy can be eliminated. So here the fifth strategy will be eliminated. And again when you compare these two, so which one is eliminating? So here the 0 is dominating the fourth strategy, and again 5 also dominating 2. So here the second strategy is dominating the fourth strategy, so this dominating can be deleted. Now remaining 3 by 3 matrix, we are going to the 2 by 3 matrix we are going to write separately. Now let us see, is there anything is dominating. So 3 is not dominating 4 because 6 is dominating minus 2, but minus 2 is not dominating 2. And 3 is dominating minus 1, but minus 1 is not dominating 2. So either first strategy, second strategy, third, fourth strategy is not dominating any other strategy. So now we can, there is another second the rule for dominance property, that is for column reduction. Second the strategy is, if a z is greater than or equal to x plus y, z can be deleted. Now let us see. So 3 plus 6, it is 9. 9 is greater than or equal to minus 1. But minus 2, minus 1 and minus 2, it is minus 3. So which is less than or equal to 2. So we can't delete the fourth. Okay. So again let us try to combine these two. So 1 and 4, 1 and 4. So 3 minus 1 is the 6 is greater than 3 minus 1. So that is 2. Correct. But when you add these two, so minus 1 plus 2, it becomes a 1. So that is minus 2 is less than 1. So that means even for the second the rule for dominance property is also we applied, but we can't able to reduce any column further. So with this we can understand that these 3 by the 2 by 3 matrix cannot be reduced by 2 by 2 matrix by this dominance property. In this case we can apply the graphical method. So we will apply graphical method. in the third step. So now find the so to solve this problem by graphical method, we need to first find the expected payoff function of player A. So now this is the final payoff matrix which we are getting from the final payoff matrix after dominance property principle. So now let us find the expected payoff function of player A. So now these are the B alternative. So that means B alternative, first strategy, third strategy, and fourth strategy, and the expected payoff function. And here we are going to calculate again expected A's expected gain. So at x is equal to 0 and x is equal to 1. Now let us first see take B alternative, that is 1. So for 1, so that means if a player B is playing only first strategy, what is the A's expected payoff function? So that becomes, let us say, x is the probability of the player A plays first strategy, so here the second strategy, and expected gain will be 3 into x, and again for the probability for third strategy will become 1 minus x. So here the A's expected payoff will become 3 into x. X is the probability of the second strategy, that is 3 into x minus 1 into the probability of getting A's expected gain for the third strategy will be 1 minus x. So that becomes minus 1 into 1 minus x. This will be equal to 4 into the 3 minus x minus 1 plus x. So 4x minus 1. Now this is the payoff function for A expected payoff function. Now let us see A's expected gain. So at x is equal to 0, the payoff function will become x is equal to 0, it becomes minus 1. And if I think now I solved the A's expected payoff function for the second strategy. So for the second strategy it will become 6 into x minus 2 into 1 minus x. So it becomes 8 minus 2. And again for the fourth strategy, the payoff function will become minus 1 into x plus 2 into 1 minus x. So it becomes how much? Minus 2 plus 2. So here there is a mistake. So then the A's expected gain will be x minus 0. At x is equal to 0, what is the value, and at x is equal to 1, what is the value. So at x is equal to 0, this will become if x becomes 0 in this function, so the value will become minus 1, and if x becomes 1, so at the expected payoff function value will become 3. The similar manner, so if x becomes 0 here, and the value will become the minus 2, and if x becomes 1, the value will become 6. And similarly, so if x becomes here the 0, the value will become 2, and if x becomes the 1, so the value will become the 1. So that is how we get the expected gain of A's expected gain. So from this expected gain, we need to plot the graph. So here the second, the third, fourth step in this the step for graphical method is the plot expected gain function of player A with respect to different alternatives of player B. So we already got this A's expected gain. So at x is equal to 0 and x is equal to minus 1. So for alternatives of 1, 3 and 4. So now let us draw a graph between this the A's expected gain. So now at x is equal to 0, these are the values. So we draw one line. So then we will say that is x is equal to 0. And we will draw another line that we say that x is equal to 1. And we will also draw one line between x is equal to 0 to x is equal to 1. So that will become a 0. So now here we will write minus 1, minus 2, minus 3, minus 4 below this line. And above this line we will write 1, 2, 3, 4, 5 up to 10. And similar manner for x is equal to the 1, and we will write the values 0 to 10 and 0 to minus 4. Now let us draw a line for the expected gain of A's expected gain. So that is equal to minus 1 to 3. So at x is equal to 0, the value is minus 1. So here is the minus 1, and at x is equal to 0, and at x is equal to 1, the value will be 3. So draw a line from minus 1 to 3, from x is equal to 0 to x is equal to 1. And for the third, this is the first alternative. Let us say this is a b1. Now let us draw a line for the third alternative. So now at x is equal to 0, so the value will become the minus 2. So here you draw a line from minus 2 to 6. So this will become the third alternative. Let us say this is the b3. For the fourth alternative of b, the at x is equal to 0 value is 2, that means this, and at x is equal to 1 value is minus 1. So you draw a line from the 2 to minus 1. So this becomes another line, that is b4. Now here A's expected gain will be max mini value. Max mini value, so it will maximize the minimum profit. So it will maximize the minimum profit. So we need to consider the minimum values, and out of that we need to maximize. So here these are the minimum. If you draw graph, this is the minimum value. Out of this minimum value, what is the maximum value? So that is what the max mini value we are going to find now. So if you take a max mini value, so wherever there, this is not the max mini value because this is the minimum value only. This is the max mini value. So where there is an intersection, that is, let us say C, the C is intersecting with the B1 and B4. That means, so B first alternative of B and fourth alternative of B. So that is only giving the max mini value where there is an intersection, that is the C. So now we need to consider the first alternative and fourth alternative. Then third alternative can be deleted because that is not giving the minimax value. So we will be considering out of 3 by 3 matrix here, we are deleting the third strategy. Then the payoff matrix becomes a 2 by 2 matrix. Now once after it becomes a 2 by 2 matrix, then we can apply augment value. So augment method. So if you find the augment value, so the augment value here will become difference between these two, that becomes a minus 1 minus 2, it becomes a 3, and here the difference between these two, 3 minus of minus 1, it becomes a 4, and augment value for column, so the difference between these two, it becomes a 3, and the difference between these two, 3 minus of minus 1, 4. So the probability of P1 will be 3 by 3 plus 4, that is the 3 by 7, and P2 will be 4 by 3 plus 4, that is 7, and Q1 will be 3 by 3 plus 4, 7, that is Q2 is equal to 4 by the 7, and the value of game is, and 3 into 3 by 7 minus 1 into 4 by 7, that is 5 by 7. So finally we can say the solution is the strategy of player A is in the probability of A of, actually there are how many? There are 4 strategies in player A, but the player A should not select the first strategy, so that is 0, and the probability for the second strategy will be 3 by 7, that is actually this, and the third strategy will be 4 by 7, that is this, and Q2, and the fourth strategy is deleted here, so that becomes 0. And the strategy of player B in the probability of B of, the first strategy is the 3 by 7, and second strategy, third strategy is deleted from the column, so that becomes a 0, and the fourth strategy is 4 by 7, and the fifth column also deleted, that is 0. So this will be the strategies of player B is in the probability of this range, and the value of game will be 5 by 7. So that is how we will apply the graphical method to solve any problem. So whenever we can't reduce the rows and columns by dominance property, we will be applying the graphical method and we will be getting the 2 by 2 matrix. And now let us see one more problem similar to this, and then we will close this class. And the seventh problem, Consider the payoff matrix with respect to player A and player B and solve it optimally using a graphical method. So player A and player B, so there are four, this is the 4 by 2 matrix, so we need to solve it. So now first, according to our the procedure, first we will apply minimax principle. So if you apply the minimax criteria, so the minimax value for the rows are 1, 1, minus 1, so minus 6. So these are the minimum values in the each corresponding row, and the minimax value will become 1. Max mini value will become 1. And let us calculate a minimax value. So here the maximum value is 6, here the maximum value is 3. So here the minimax value will become 3. So here the minimax value is not equal to max mini value, so it is not a pure strategy. And let us check the dominance principle. So if you check the dominance principle, so the strategy 1, now we already we will first see the column reduction. So column reduction, 3 is dominating 1, but here 1 is dominating 3. So either 1 or 2 is dominating each other in the column reduction. And let us see the row reduction. And this is the row, and 3 is dominating 1, but here 1 is not dominated by 3. And here let us compare this 3, and 5 is dominating 1, but minus 1 is not dominating. 6 is dominating 1, but minus 6 is not dominating 3. And let us compare these two, and the 6 is dominating 3, but minus 6 is not dominating 1. And let us compare these two. 5 is dominating 3, but minus 1 is not dominating 1. So by seeing all these combinations, so no player, the strategy is dominating other strategy, so we can't reduce the rows or columns by dominance property. So we have to take this the 4 by 2 matrix for solving. So we can apply the graphical method for solving this. In the graphical method, the first we need to find the expected payoff function of player A. So for this we will be finding the expected payoff function of the player B now, because these are okay. Let us see that. So now the A's alternatives, because there are 4 alternatives for A, because only 2 alternatives for B, so we will be taking the expected payoff function for player B only. So expected A's alternatives are 1, 2, 3, 4 and 4. So here 1, 2, 3, 4, and we are taking. And B's expected payoff function, so here it is actually B's expected payoff function will be, so here if that means player A plays only first strategy, and expected the gain of B will be the 1 into y. So here we are taking y in order to eliminate the confusion by taking y. So if you take again x, that will be again confusing, because x we used for payoff function of A, for payoff function of B we will be using y. So here, and for player A, and 3 into y plus and 3 into 1 minus y. So that becomes a minus 2 plus 3. Sorry, there is a mistake here. So 1 into y plus 3 into 1 minus y. So here is 1 actually. So here 1 into y. So then finally minus 3 plus y, it becomes minus 2 and plus 3. And then for a second the alternative, and 3 into y plus 1 into 1 minus y, that is equal to 2y plus 1. And then for third alternative, and 5 into y minus 1 into 1 minus y, so that becomes a 6y minus 1. And again for fourth alternative, 6y minus 6 into 1 minus y. And now again B's expected gain will be, so here if y becomes 0, so this B expected at y is equal to 0 will be 3, and if y becomes 1, so the value will become 1. So again here if y becomes 0, so this value will become the 1, and y becomes 1, the value becomes 3. and here if y becomes 0, the value becomes 1. If y becomes 1, the value will become 5. So for the fourth alternative, and if y becomes 0, this will become minus 6, and if y becomes 1, it becomes a plus 6. So we can able to this is how we will be calculating the b's expected gain. Now let us go to the fourth step. The fourth step says plot the expected gain function of player B with respect to different alternatives of player A. So now we already got this in the previous slide. Now let us try to plot this. At x is equal to y is equal to 0, 0, you draw one line, and at y is equal to 1, we will draw another line, and we will be drawing one more horizontal line at 0, and the above values will be increasing from 1 to 3, 10, and the below values will be minus 1 to 2. And first one, it is becoming actually 3 to 1. So we need to draw a line from the x is equal to y is equal to 0, so 3, and at y is equal to 1, 1. So we need to draw a line like this. So that becomes the 1, 2, 3, that becomes a1, sorry, this is the a1. And then the second one is the 1 at x is y is equal to 0, 1, and at the y is equal to 1, the value will be 3. So this becomes a a2, and a2 is written here. And the next line will be minus 1 to 5. Minus 1 is here, and 5 will be here. So that is the another line. So that becomes the a3. And finally minus 6 to 6. So this here is the minus 6, and here is the 6. So that also I drawn. So that becomes the 4, or the a4. Now here we need to see, when we are taking the b expected gain, the b expected gain will be mini max value. Mini the max value. So we are going to take a minimum value out of the maximum the losses. So this is the maximum losses. So we need to take the minimum losses wherever there is an intersection. So this intersection is taking place between the a3, a1 and a2. So a1 and a2, and even a1 and a3 also intersected with the same point. So you can take any two the alternatives. So then we can able to solve this. So here the intersection is at C. So now we will take the 1 and 3 alternatives. Exactly, if you draw the graph, so there may be a intersection at A1 and A3. So that is why it becomes a 2 by 2 matrix. So if player A's are left as a 1 and 3, and player B left 1 and 2. So now it becomes a 2 by 2 matrix. So we can easily apply augment method. So if you apply augment method, so here the augment value will become the difference between these two, 5 minus of minus 1, 6, and here augment value becomes the difference between 2, 1 minus 3 minus 2, but determinant it becomes a 2, and again augment value for column, so 3 minus of minus 1, it becomes a 4, and the 5 minus 1, it is 4. And similarly we will be calculating P1. P1 is equal to 6 by 6 plus 2, so 6 by 8, that is nothing but 3 by 4, and 2 by 8, that is nothing but 1 by 4, and Q1 is equal to 4 by 4 plus 4, that is equal to 1 by 2, and Q2 is equal to 4 by 4 plus 4, that is 8, so that becomes 1 by 2. So the value of game is, let us say the Q1 into 1 into 1 by 2 plus 3 into 1 by 2. So value of game is 2. So the finally solution is the strategy of player A is in the probability of 1 and 3 is selected. So here the 3 by 4 comma 0 comma 1 by 4 and 0, and the strategy of player B is in the probability of 1 by 2 comma 1 by 2. The value of game is 2. So this is how we will be solving in the graphical method. So the graphical method, there may be A's expected gain and B expected gain. So whichever the alternatives are more, so then opposite to that we are going to find the expected gain function. Then we will be drafting the graph. Then if suppose if it is A alternatives, and we need to make the minimax value, and if it is a B alternative, we will be making the max mini value. So that is how we are going to solve with this graphical method. So let us conclude this the game theory with these conclusions. So game theory provides a systematic approach to decision making in competitive environment, helping identify optimal strategy for players. The pure and mixed strategy games help determining strategic moves when players either have a clear best choice or must use probability to make decisions. The dominance property simplifies the game, making it easier to solve by inferior strategies without losing accuracy. Thank you.